We are going to talk about topic 3.9, inverse trigonometric functions. One of the main things we are going to be talking about is inverse trigonometric functions, and that we're only switching the input and your output values. The main thing about that when you do have an inverse trigonometric function is that when you do inverse the trigonometric functions, your measurement will always be an angle measurement. What I mean by that, it's always going to be in radiances. We're always going to be doing radians, so like pi over 3, pi over 6, and so on. So it's never going to be 1/2 or 2 or 3. It's always going to be in radiant measurements. It could also be in degrees, but in pre-cal, we tend to do everything in radians, which is pi over 3, 2 pi, and all that stuff. The next thing that we need to look at is inverse trigonometric functions. We usually write it as inverse sine of x or arc sine of x. And we always say arc sine of x. Sometimes we say inverse, but this is literally just the arc sine of it. So these are the two ways you can see it. They mean the same thing, it's just different notation. And when we're talking about it in words, we usually say arc sine of x or arc cosine of x and so forth. So for example, 1, it says write sine of pi over 6, which is not an inverse. And we know that sine pi over 6 equals 1/2. And if you want to write it as an equivalent fraction as arc sine, what technically all that happens is you're switching these two pieces and making the sine into an arc sine. So now that means you have arc sine of that to the 1/2 is pi over 6. Or you could have arc sine of 1/2 and is equal to pi over 6. So basically our answer should always be in radians, okay, or the angle measurement when that corresponds to the unit circle. So our trig functions have restrictions for inverse sine. So the whole unit circle doesn't work for it. So if you look at a graph, the arc sine or the sine function, basically this is your sine function right here. And in order to be an inverse function, your domain, the only numbers that we will take are between negative pi over 2 and pi over 2. On the next slide, you're going to see something that makes a little bit more sense. But this is basically the domain, from there to there, for a arc sine. And for the cosine, so for your cosine one, okay, again, it's this piece right here. If you notice, it was from 0 to pi. But, and that's what it's going to be for arc cosine. And then lastly, for tangent, it's the same one that we have for sine, just also because it's the vertical. On the next slide, it's going to give you a better picture of it, so you can see it more like in reference to the unit circle. So something important about inverse trigonometric functions is that where the domain is restricted, or where the inverse actually works. So like for the arc sine function, it works from pi over 2 to negative pi over 2. Basically, it only works in the first quadrant and fourth quadrant. You're not using the second or the third. That means all your answers have to be between here or in the negative direction. So clockwise and counterclockwise. It does not go all the way around. So your answers have to lie in the first or fourth quadrant. For cosine, it is from 0 to pi. So only the first and second quadrant. That means all your answers have to be there. That's it for the domain. And then for the domain for tangent, range, it has to be from, again, just like sine, from pi over 2 to negative pi over 2. So again, it only works in the first and fourth quadrant. So if you're looking at these problems and you want to see where we have negative square root of 2 over 2, just like we did before, you're going to use it like we did for the regular unit circle. So I quickly made a little first quadrant here. Everything in blue is sine and cosine. Everything in red is tangent. So we're going to be basically using the same thing that we were doing before, but now we're going to look, okay, where's cosine negative square root of 2 over 2 in a specific quadrant? So if you look at cosine, cosine is negative. Either first quadrant, everything's positive. In second quadrant, that's where it's negative. And we know that cosine, it's negative square root of 2 of 2 when it's equal to pi over 4. It's on this side, so that means when we're going to do, visually so you can see it, we're going to have a fourth, right? This is pi over 4. This is 2, 3, 4. We know our answers can only be in the first quadrant or in the second quadrant for inverse cosine. So we know that here at pi over 4, at this specific point right there, it's positive square root of 2 over 2. But at this point right here, that's going to be negative square root of 2 over 2. So that means my answer is going to be 3 pi over 4. Okay, now we're doing arc sine. So we know that for arc sine, it has to be in the first quadrant or in the second quadrant. So either our answer has to be positive if it's up here, if it's negative, it's down here. Since I know that my answer is negative, that means I'm looking for values down here in quadrant 4. Okay, so that means when I'm doing this, if you visually want to kind of draw it, think about it like you have in thirds. You have, this is pi over 3. This is going to be your next, pi over 6. And then this is your negative pi over 6, negative pi over 3. And we already know this would have been positive square root of 3 over 2. That means this is going to be negative square root of 3 over 2. So your answer has to be negative pi over 3 because you cannot go all the way around. You could only go from first to second quadrant. You can't go all the way around. So it's either up here or down here. So they're going to be either positive or negative. That's basically it. And then lastly for tangent, okay, tangent, we're talking about where it is square root of 3. Well, if you look at the little unit circle that I gave you, tangent square root of 3 right here at pi over 3. So technically, your answer is just pi over 3 and you're done. Easy peasy. So on this one, you basically have P, and P is reflected over the y-axis and then over the x-axis over the specific lines. All they want to know is where the arc cosine of a positive x is, where the inverse sine of negative y would be. What letter would it be? So for example, we know that arc cosine is in the first and second quadrant. And then we are talking about a positive measurement. So we know that arc cosine is positive in the first quadrant. So that means for the answer for this one is just letter P. Done. Okay, for the next one, which is inverse sine, arc cosine of negative y, we know inverse sine is either in the first quadrant or in the fourth quadrant. Since we're talking about a negative y, we're talking about flipping over this side. So that means my answer would be S. It would be in the fourth quadrant. So it would be the S point. Okay, I want you to pause it and then try C and D and then see if you get the same answer I do. Pause. Okay, so if you actually worked it out, again, we're talking about cosine, and cosine is positive in the first, or sorry, not positive, it's located in the first or second quadrant. Since it's a negative x, we know it's going to be in the second quadrant. That means it's going to be Q. Okay, and then we're talking about tangent, and tangent has to be either in the first or in the fourth quadrant, just like sine. Since we're talking about a negative, we know it's going to be, again, S, because this is where it's negative, this side is where it's positive. So that means this is also S.